This diagram shows the leap you are making today. We are leaving the colorful drag-and-drop blocks of Scratch behind and stepping into writing real text-based Python code. Every text-based program you write relies on one foundational cycle, shown here in this pipeline. You take data in, store it in a variable, and output an answer. Here is our Python loop. We print a question, catch the reply in a variable, and print a greeting. Notice the syntax rules. Text inside speech marks prints exactly. A word without speech marks fetches the variable's value. The logic remains the same as in blocks, but you now control every individual character. This transition requires total precision. The computer only follows instructions that are syntactically perfect. This panel lays out the three main data types you need to know to build tools like calculators. You have integers, which are whole numbers, reals or floats, which contain decimals, and strings, which represent text. When you ask a user for a number, Python's default behavior is to treat that input as a string, a word, rather than a mathematical value. To actually do math, you have to use a process called casting, wrapping your input in an int command so Python knows it is a solid integer. This worked example shows exactly how that looks in practice. The variables a and b successfully capture the string inputs, cast them as integers, and multiply them to give us an answer of 20. There is an exception when you divide. As you can see in this breakdown, dividing 12 by 3 results in 4.0. Python automatically processes division as a real number, or float, even if both of your starting inputs were whole integers. Because a computer will only do exactly what it is told, you have to explicitly define these data types. Otherwise, the program will simply crash because it does not know how to multiply words together. Once you have your data, you can make your program evaluate it using selection. This flowchart diamond illustrates how a program checks a condition, branching into different paths based on whether the answer is true or false. To trigger these branches, Python uses an if statement. You write a double equal sign to ask the program, does it equal this value? That is completely distinct from a single equal sign, which simply assigns a value to a variable. Let's test this out. Try writing a program that checks a user's score. If the score is 50 or higher, print pass. Otherwise, print fail. Pause the video here and give it a shot. Here is how you structure that logic. We set our condition. If score is greater than or equal to 50, it triggers the print pass branch. The else command catches any other outcome and prints fail. Adding these if and else statements allows your code to make logical choices, turning a rigid sequence into a dynamic program capable of reacting to user input. Now we combine variables, casting, and selection into a single project, a multi-operation calculator. This interface shows our required inputs, the first number, the mathematical operation, and the second number. This time, instead of casting our numbers as integers, we wrap them in the float function so our calculator can correctly process inputs with decimal values. We then build a chain of conditions. An initial if statement checks if the operation string is a plus sign to perform addition, while a series of elif statements checks for subtraction, multiplication, or division. By completing this calculator, you have applied the three core pillars of text-based programming, creating a sequence of inputs and outputs, defining strict data types, and using selection to branch your logic. You have successfully moved from visual blocks to writing and debugging your own code. Build on these foundational skills with one final challenge. Write a program that asks for a number and determines if it is positive or negative. Keep coding,